Okay, so today we're going to really dig into this chromatography thing.
Yeah,
You know how we purify all those valuable bioproducts?
absolutely.
Seems like it's pretty crucial.
Oh, it's everywhere. It's a
Yeah.
workhorse for sure.
You sent me some really cool sources on this, and I think our mission today is to try and break down these core principles, and
Oh,
all these different types of chromatography
yeah.
so that anyone listening can understand the power of this separation method without getting bogged down with all the really technical stuff.
Yeah, absolutely. It's really like a molecular sorting system at
Okay.
its core, and we're trying to separate molecules based on how they interact differently with a stationary phase
Right.
and a mobile phase.
Okay, so
Think of the mobile phase like a carrier fluid. It can be a liquid or a gas.
it's like the thing that's moving through.
Exactly. And the
Yeah.
stationary phase is like something that's fixed. It's not moving.
Okay, and that's usually inside this column.
Right, often inside a column.
I see. I
Yeah.
see.
And so what happens is you've got your sample, it's traveling with the mobile phase through the column.
Mm-hmm.
But the molecules in that sample, they're going to interact with the stationary phase in different ways.
Oh.
Some are going to be stickier,
Oh, good.
to the stationary phase than others.
Like it's almost like some molecules want to stop and chat for a little
Yeah.
bit longer.
Yeah, exactly. And that's going to make them move through the column at different speeds.
Oh, that makes sense.
And eventually what we do is we wash these separated components out of the column. We call that elution.
Okay.
And then we need to figure out what we've got.
Right. We need to see what's in there.
Exactly. So we use detection methods
Okay.
to measure different properties of what's coming out.
Okay.
And that gives us a profile of the separation. And
And
then,
then we can even isolate specific purified components.
yeah, exactly.
Right.
We use fraction collection to gather them as they're eluting at different times.
Oh, that's really neat.
Yeah.
So, okay, we've got the basic idea. Now let's look at some of these different types.
Right.
First one that jumped out to me was absorption chromatography,
Yeah.
often called liquid-solid chromatography.
Right.
So what's going on there?
So in adsorption chromatography, you've got a liquid mobile phase. It's carrying your sample over a solid stationary material, so something like silica gel is commonly used.
Okay.
And the separation happens because different molecules have different affinities for that solid surface.
Okay.
So some are going to stick more strongly and move slower.
Okay, so it's all about the clinginess to the surface.
Yeah, exactly.
Okay.
Different levels of attraction.
Gotcha.
And then another type is ion exchange chromatography, or IEX.
IEX.
And here, charge is super important.
Oh, so we're using like magnets or something?
Not quite magnets, but we're definitely using the idea of positive and negative charges.
Okay.
So in IEX, the stationary phase actually has charged groups,
Okay.
and molecules with an opposite charge are going to be attracted and bind to that stationary phase.
So it'll stick there.
Exactly.
Okay.
And then the molecules that have the same charge as the stationary phase, they're going to flow right through.
Okay, so it's like they're repelling each other.
Exactly.
Oh.
And then we can actually release the molecules that have bound to the stationary phase by changing the ionic condition.
Oh, that's clever.
And so this is often used to purify specific proteins based on their charge.
So you've got like a specific protein you're trying to get out.
Yeah, exactly.
You use its charge to do that.
Yeah.
I see. Very cool.
Yeah.
Another one that came up was HPLC,
Yes. HPLC.
high performance liquid chromatography.
Yeah.
That sounds pretty intense.
It is. It's really versatile.
Okay.
So what's cool about HPLC is that it uses very fine stationary phase particles and high pressure, and that gives us much sharper separations.
Okay.
And that's really important for analyzing complex mixtures.
Gotcha. So it's like getting a higher resolution picture
Yeah, exactly.
of what's in the mixture.
And what's really fascinating about it is that it can actually use different separation modes.
Oh, wow.
So it can do the adsorption that we talked about. It
Mhm.
can do IEX,
Okay.
but it can also do things like size exclusion and affinity.
Wow.
So it gives us a lot of control.
So you can fine tune exactly the separation that you want.
Yeah, exactly. And the smaller particles under high pressure mean more interaction points, and that gives us better resolution.
Oh, I see. That makes sense.
Yeah.
So it's like HPLC can be all the other types of chromatography.
Yeah, kind of like an all-in-one system.
That's really cool.
Yeah.
Another one that came up was size exclusion chromatography.
SEC.
SEC, yeah.
Yep.
And that one is really all about size, right?
Exactly. So it separates things based purely on molecular size.
Okay.
So the stationary phase here has porous beads,
Oh, okay.
and the smaller molecules are going to get trapped in those pores, and they take a longer path.
Oh, I see.
Whereas larger molecules, they just can't enter the pores, so they're going to pass through more quickly.
Oh, that's a really cool way of thinking about it.
Yeah, so it's like sorting by physical dimension.
Like a big sieve.
Yeah.
Gotcha. And this is often used to remove aggregates or very large molecules from a sample.
Okay. So, like if you're working with proteins,
Exactly.
you don't want those big clumps.
You want to get rid of them.
Gotcha. And then the last one that we saw was hydrophobic interaction chromatography.
HIC.
HIC. Okay.
That's
And hydrophobic, that means it doesn't like water, right?
Exactly.
Yeah.
So this type of chromatography relies on how much molecules dislike water.
Okay.
So the stationary phase has these water-repelling or hydrophobic groups.
Right.
And in high salt conditions,
Right.
the hydrophobic molecules in your sample are going to interact more strongly with that hydrophobic phase.
Gotcha. So they're like, oh, I don't like this water. I'm going to stick to this.
Yeah, exactly.
All right.
And then we can actually release those molecules by lowering the salt concentration.
Okay.
So we're separating things based on their level of hydrophobicity.
That's really cool.
Yeah.
So, I mean, with all these different options,
Oh, I know, right?
how on earth do you decide which technique to actually use? Well, it really all comes down to what is it you're trying to purify?
Right.
What are the specific characteristics of that bioproduct that you want?
Mm-hmm.
And what are you trying to separate it from?
Like, what are the impurities?
Exactly. So each type of chromatography we've talked about exploits a different fundamental property of molecules.
Okay.
So it's either their stickiness or their charge,
Yeah.
their size, or how much they interact with water.
So you really need to match the technique to the molecule,
Exactly.
to what you're trying to do.
Matching that separation mechanism to the molecule's properties is key.
Okay, so really the big takeaway here
Yeah.
is that chromatography is this amazingly flexible toolkit for purifying these bioproducts.
Absolutely.
And it does that by taking advantage of the different properties of the molecules themselves.
Right. And I think what's so fascinating about this is that this very simple idea
Yeah.
of differential interaction, some molecules like to move, some
Yeah.
like to stay put, allows us to do these incredibly precise separations.
Really complex mixtures.
Yeah, even in the most complex biological mixtures.
That's so cool. And it kind of makes you think about, other types of separation processes
Yeah.
that are around us. Even just something like a coffee filter,
Right.
separating coffee grounds from the
Yeah.
liquid.
Yeah.
Or you think about how different sized grains of sand
Yeah.
settle in water at different rates.
It's the same principle.
It's all this differential interaction.
Yeah.
So what other processes, even things that seem completely unrelated,
Right.
really rely on this idea of different components interacting differently
That's a great question.
with their environment? It's definitely something to think about.
Yeah, for sure.
Thanks for coming on today.
My pleasure. Thanks for having me.
That was a really great discussion
Yeah, I enjoyed it.
about chromatography.
Me too.
All right.
Thanks. See ya.